Hello my learners, welcome back to today's videos where we are going to be introducing the other new topic after we have done with the subject of the formula. And where we are to take ourselves into the new topic about the exponential and logarithmic equations. Like it's a little bit longer topic, but still more, we'll try to make it at least be briefed by taking things in the, we'll be discussing more especially the main points of which, and I have all hope that we'll be together until the end of it. But always please remember to revise these concepts we're discussing here. There's a link down here, always do that. Because maths is connected, you don't just have to focus on one area, no, the whole syllabus has to be at least revised. So as we are targeting at finishing the syllabus, make sure that all the topics are revised, the ones we have discussed. So the link down here is there going to give you a guide for that. So please do the needful. Right here in this new topic about the exponential and logarithmic equation, we would first of all need to know the aim of this topic, and after we have to see the objectives that are going to guide us until we accomplish all the aims. Right, the aim of this topic here is simply to help you learners to know how you can, that's the aim, solve what we call them exponential equations, right. So what we need to do is this, at the very end of this topic, after I've discussed all the lessons, you should be in the position to solve what we call them as exponential equations. Secondly, you should be in a position to solve, as the title here, logarithmic and exponential. You need also to know how to solve what we call them as logarithmic equations. Right, so these are the main two aims of this topic. So let us be together. Whatever we do, you should be in the position to assess yourself. I moving in that channel that at the very end I'll be in the position to solve the exponential equations and again solving the logarithmic equations. Right, so these are the two aims of this topic. Now let us look at the objective that will guide us until at the very end, so that we manage to know how to solve these two types of equations. The objectives of which are as follows. I'll just give up the lineup here as quickly as I can. 1, we should be able to know how to express numbers. Expressing numbers, that's as the powers of given basis. Secondly, we need also to know how to model what we call them as exponential. This is exponential equations, right? Then after we have known how to model out, then we should be in the position to know how to solve what we have modeled. So solve the exponential equations as such. After that, now we concentrate on the logarithmic part, where you need also to know how to model, that's the logarithmic equations. So if you have known how to model out the logarithmic equation, then what you need to do then next is to solve these equations. So you need again to know how to solve the logarithmic equations. After that, we can then going to venture ourselves into what we call the laws of logarithms. So we have to know the laws of that's logarithms. Then thereafter, we also need to know how to solve the equations. These are logarithmic equations. Right, now by using the rules which have been what? Developed. Right, so these are the objectives that we take us through until we finish up everything that we have planned. That's the aim, solving logarithmic and exponential equations. So we're going to express the numbers as powers of the given basis, modeling the exponential equation, solving exponential equations, then modeling up logarithmic equations, solving logarithmic equations. Laws of logarithms has to also be established, and thereafter we're going to solve the logarithmic equations using the rules which have been developed. Right, so now let's tune ourselves and be there, have a paper and also maybe a calculator where necessary. Materials should just be with you because there's a lot that we're going to discuss here in this topic. Right, so without wasting much of the time, let us take ourselves into the first objective where we would need, specifically, get to know issues about the first part of the equation. You know, this topic is more like two in one, exponential and logarithmic. So for us to understand this one better, I would prefer that if we take it in parts, we first of all deal with one, and therefore thereafter we're going to venture into the other one. Because if sometimes we do them together at the same time, we might get confused, may not be able to understand the concept fully. So let's first of all discuss something about the exponential equations. Exponential equations. Right. After this, we'll take the logarithmic equations. So first, let's first of all define what an exponential equation is all about. That is more like modeling up the exponential equations. So for us to understand what an exponential equation is, we all know what an equation is. We that time defined that is just like something like a balance that is able to give the relationships amongst the variables that exist within it. So types of equations which are defined as exponential, what are these type of equations we are talking about? So for us to understand what exponential equation is, we need first of all to know and understand the terminology exponent. What is an exponent? Because exponential is more like just like an adjective word to a noun equation. So first, let's discuss the exponent. So how to discuss the exponent is where now we are going to express the numbers in a certain power of a certain basis, right? So let's discuss the exponent first, what it is, then after we will have to model up the exponential equation. Consider a number, for example, 81. And any other number, like maybe talk of 32. In mathematics, at times, we prefer to write numbers in different forms. Here, I'm trying to define what an exponent is so that we have to take ourselves into understanding what an exponential is. So to understand that one, let us consider some numbers like 81 and 32. These numbers, you may sometimes prefer to write them in different forms. Say, for example, you can decide to write the numbers in factors. Like, say, for example, you can prefer to write 81 in factors of 9, or say in factors of 3, things like that. And again, 32, you can prefer maybe to write it maybe in the factors of 2, things like that. Writing a number in factors which are identical. In this case, that's what we're talking about. So, for example, 81 can be written in factors of 3. It's just like asking yourself, how many 3s can I multiply in order to get 81? And again, 32 can be written sometimes in factors of 2. And that's a matter of asking yourself to consider how many 2s can you multiply to get what? 32. So, like in this case for 81, if I would prefer to express 81 factors of 3, it means in this case, I'll have 3 multiplied by 3 multiplied by 3, which gives me 9. In this case, multiplied by 3 again. 3 times 3, 9. 3 times 9 times 3, 27. Times 3 gave us what? 81. So in this case, we have got 4 3s which are multiplied to give us 81. The same 32 can be written in factors of what? Factors of 2. Like say, for example, you may be able to consider 32 in factors of 2, whereby you try to find out how many 2s can you multiply to get 32. So in this case, you go like 2 multiplied by 2 give you 4 times a 2 give you what? 8 times a 2 that give you 16, and finally times another 2 that give you 32. So which means in this case 32 in factors of 2, it means we have to multiply 2 5 times in order to get what? 32. And here 81 has to be multiplied in fact, okay, 81 is just like 3 multiplied 4 times to get what? 81. So in this case, if we write 81 in factors of 3, like 3 times 3 times 3 times 3, and 32 in factors of 2, like 2 times 2 times 2 times 2 times 2, in mathematics, this type of writing 81 in factors of 3, 32 in factors of 2 can be briefed in such a way that you try just to consider, like say 81, you ask yourself, what are the factors of 81 in this case? Oh, it's a 3. Fine, how many 3s do we multiply to get 81? You just count 1, 2, 3, 4. So that number of times you multiply that factor, you write it on top like this here, like that. And again, if you can also look at 32 in factors of 2, you also have to find out how many 2s are you multiplying in order to get 32. So you find that there are 5 2s that you multiply. But now in mathematics, how we write that one? We write that one brief like 32 is equal to 2. Then the number of times you multiply a 2, that one is written on top like that. So in this case, you talk of 2 to the power 5. Think like that. Right, and what have you? You can have several examples, have 100, and that one can be expressed in factors of 10. Then factors of 10, you talk of how many 10s do you multiply to get 100. Then talk of 2 10s. We have to multiply 2 10s are required in order to get what? 100. So you write 10 as a factor of 100, and the number of times you multiply a 10, you write on top like that. Think like that. So now, if you can look at this type of presentation of these numbers, 81, 32, and also 100, you may be able to consider that this 81 is written in 2 forms, in 2 categories of numbers. One is down, another one is on top, another one is down, another one is on top, another one down, another one is on top. That applies for 32 and 100. Where this number that is down here is a factor of 81. And here 2 here is the factors of 32. And here 10 here is the factors of 100. These lower numbers. But these numbers which are on top here, they are telling us how many times do you multiply a factor of 81 to get 81 itself. Oh, I multiply the 3 4 times to get 81. The same 5 times to get 32. The same I multiply 10 2 times to get 32. So now, these numbers which are up here, talk of a 4, talk of a 5, talk of a 10. Those numbers are the ones which are defined as what? Exponents. Right, so it's more like an exponent, it's just like a power that tells how many times to multiply a particular factor to get a particular number. So like here I multiply 3 4 times to get 81. This 4 is defined as the exponent. And here I multiply 2 5 times to get 32. So it means the 5 is defined as the exponent, or you can call it the power such. And then if I look at the 2 here, tells me how many times do I multiply a 10 here in order to get 100. So this 2 is defined as what? Exponent. Right. But this number down here, which we call it a factor of 100, 2 here is factor of 32, or 3 here is a factor of 81. That number has got its own definition again. These lower numbers, you talk of a 10, you talk of a 2, and a 3. These ones are defined as what? Bases. Right. So in short, it is possible at times to sum numbers. Numbers can be expressed in the form of a base and the what? And an exponent. So be able to understand what an exponent is, what a base is. A base is simply a factor of a particular number, while an exponent is simply the power, or call it a number that tells you how many times do you multiply a base to get a particular what? Number. Right. So this is very important. Each time we are talking issues about the what? Exponential equations as such, we need first of all get to understand fully what an exponent is. So exponent is simply a power. Some they also term the same exponent as an index. So that exponent, which is a power, you can also call it as what? An index. So if you talk of an index, we talk of a power, we talk of what exponent, all those are referring to the same number that tells us how many times do you multiply a particular factor of that particular number in order to get that same number as such. Right, so that's it about the exponent. A number that is on top of a particular factor. Right, so if I'm to present this format in here, like 81 is equal to 3 to the power 4, which is exponent 4, 32 is equal to 2 to the power 5 or exponent 5, 100 is equal to 10 to the power 2 or exponent 2, then I can have a presentation of these ones in one form as the y to be considered, like say for example a number could be like 81, could be 32, could be 100, and this it means y can be expressed into this light up, like say talk over m and again a power t. Look at that. So which means if I light y is equal to m to the power t is the form of this presentation here, 81 is equal to the power 4, the same 32 in this form, this 100 is the same in that form. So all these numbers here which are expressed in this presentation are just in that form. So now if you look at this presentation here, this is just like an equation that talks about the what? Exponents, and also talk of the what? The basis as such. Y is equal to m to the power t is as good as writing 100 is equal to 10 to the power 2, and writing a 32 is equal to 2 to the power 5, 81 is equal to 3 to the power 4, and all presentation of such kind, okay, give us equations which we call them as exponential equations. So in short, if we express a number like this one and form an equation of this kind where there's an exponential which is being portrayed, such type of equations are referred to as what? Exponential equations. Right, so let's try to understand it. That say each time we talk of an exponential equation, we talk of equations which are expressed in this format here. Try to understand what is the meaning of this t here, variable t. What is the meaning of this variable what? Variable m. What is the meaning of the variable what? Variable y. So you can match this one into that manner as it is up there. Right, so that's it what we have here. So in short, I will just take down here without writing a lot of things on the board here. I'll just take to say all are equations expressed in the form talk of the y is equal to m and the t up there are known as the exponential what? Equations. Right. So it means exponential equations, they always have to at least have certain variable which has got an exponent. So try to understand what an exponent is. It's just a number on top that tells you how many times to multiply a number down there, which you call it a base as such. Right, so that's it about it. Now, if now we are there now, going to be asked to know how to solve such type of equations. You know, the equations are so many. Previously, we've been discussing about what? Call it the quadratic equations. In the first topic, you would see the principles which were attached to that. Talk of issues of factorizations and the like. Those ones are related to that type of what equations. And just have a linear equation aside that have got their own principles of solving. You just arrange the like terms together. So here now we have got what we call the exponential equation aside. It's be like now, suppose I'm asked here to wake up the value of 18 in this equation. How can I find this value of the t, which is an exponent? And now in the same equation here, I will be asked maybe to find the value of y. How do I do? Or say maybe I would like to find the value of m. How can I find out that equation as such? Right, so here I'll give you at least 2 examples that should help us to know how we can solve such presentation of the equations. Right, so let us take this example here. But first, let us get to know what we'll be doing here. Let's have this one, solving talk of the exponential equation Z. Right, so how do we solve the exponential equations? So let's have examples here, just a few. Solve the equations. A, let's have that's the 2 to the power x is 32. B, 27 is equal to 9 to the power x. And C, just 3, will not take time, is equal to 0.25. Right. So look at my presentation of the examples which I've just given you on the board. You are going to realize that from what we've just discussed of that format of the y is equal to m to the power t, you'd be able to see that these equations, 3 equations here, are a part and parcel of this. Like in the first year, you can be able to present y as 32. In the second, that one, y is 27. In the third one, you can say y is 0.25. And you talk of the exponent t in this case, you can present it as x. Exponent t here is presented as x here. Exponent of t here is presented as m. While the m here is just like a base. The base here is the 2. The base here is 9. The base here is what? Is 8. So all these ones are exponential equations. So how do we solve such type of equations? Right, I'll just give you only one statement that is needed and we'll go by that. Just simple one. And each time we are dealing with such of equations, let us be able to follow that principle. Right. How we treat this talk of the exponential equation, like here we need to find x, to find m. What we need to do is simply just a matter of knowing the process of expressing. In short, you need just to express terms to the same basis. That's all. If you are given an exponential equation, this is solve this one, solve that one, solve that one. The first that you could consider in your head is just a principle of expressing the terms to the same basis. Right. If not, try to express these terms to the same, that's the same exponents, or say powers, exponents. Right. That is the first step that you would do. Right. So for example, we have got a here. We are given 2 to the power x is equal to 32. Right. You understand that what you have here in the left hand side, this 2 is the base, this is the power. But 32 here is not expressed to such type of presentation like the left hand side. We can't see the base here. It's just like a number that is 32. But this term here is expressed to base 2 and the exponent is x. So now what you do here by the principle that is up here, you need to express the terms to the same basis. First of all, consider that one. If that one fails, you go for the same exponent. We can be able to express here 32 to base 2. You first of all think of the same basis that is already there. This term has got base 2. Can I manage to express 32 to base 2? So like here, you find that this is true. It's just a matter of finding how many 2's do I multiply to get 32. Then you have that 32 expressed in base 32. So here you tell me that 32 can be expressed to base 32 in such a way I need 5 2's in order to be multiplied to get 32. So now, if 32 has been again expressed to base 2, you find that this equation has got terms which are of the same basis. Left hand side, the base is 2. Right hand side, the base is 2. So now in an equation, as much as you say, this left hand side is equal to the right hand side. And the terms are of the same base. there's no way you can learn out from this story about the talk of relationship of the what? Exponents. So if bases are the same, then obviously you have to expect the exponent on the left hand side, which is x, must be the same as what? As the exponent on the right hand side. Otherwise, if these ones will not be the same, then we should not talk about this equation here. Then this one must be not equal to. So that's it. If bases are the same, we also expect have the exponents being the same. So here, which it means in this case, by this principle here, we have to expect that the power of x is 5. Right. Now, let me just solve this other one. Then the last one, the C, you are going to attempt it as an exercise. Right. For the second one, we have, let's say 27 is equal to 9 to the power x. Now, it's not always true that, say, as the mathematician, that when we say expressing the term to the same basis, sometimes it might not be always direct. So as the mathematician, expect such type of situations and be able to consider what type of principles that you could do in order to work out the that type of what situation. Like for the example, the first example here, it was very easy for us to express the 2 to base what? A 2, based on the existing base. But now if we can look at this second example, 27 is equal to 9 to the power x. You'll be able to see that it's not all that possible to express 27 to base what? To base 9. If you talk of 2 9s, you have a 9 times 9, that gives you what? 81. You have got 3 9s, it goes further. So it means here 27 cannot be expressed to base 9 as it was here 32 was expressed to base 2. So what you do in this situation is we change the base. We decide which base can be used in this case in order to fit both situations. That's the right hand side and the left hand side. Right, so you theorize in that case. So this is a little bit different example given the direction on such type of situation where bases cannot be expressed based on the existing base, one of the terms. So here you are advised most of the times to have to this situation to decide what base can be used for 27 and the base for the 9. So here you may decide to use a base 3. Here, look at this. 9 can be expressed to base 3. You change the base, which you mean now 3 to the power 2. Since there's already an exponent up here, which is the power, then since we have expressed the 9 to the power 2, it means this new exponent has to multiply by what? Existing exponent. So it means you have got a 2 here times x, you get what? 2x. So now you look at the 27. Here a base now has been changed to a 3 from a 9. So you find that 27 can also be expressed to base 3, which gives you 3 to the power 3 in that case. So that's what we do. Bases cannot be expressed to the same, okay? Terms cannot be expressed to the same base. Try at least to consider a different base as we have done here. So by the first example, where we said if bases are the same, then definite exponents must also be the same. That stand will also be taken here. Base 3, which means the exponent 3 should be the same as exponent what? 2x. So if you are there to find the value of x here, you just have divided by 2, divide by 2. And what you have here, it is 1.5 is equal to what? X as such. Right. So what is what we have here? Now, as a mathematician, try again to understand the meaning of this solution here. You don't just apply to say x is this, and here we say that x is 5. What it tells us here is just like the moment I've found x is 5 here. This tells me that I have to multiply 5 2's in order to get what? 32. It means the 2 should be multiplied 5 times to get what? 32. That's what it means here by this exponent. The same way, if I found that x is 1.5, what does this tell me? This tells me that I have to multiply this 9 1.5 times. You can't multiply this 9 2 times. If you multiply it 2 times, it will be 9 times 9 is 81. But now, then it means the number of times you multiply the 9 should be less than 2. So in this case, it tells that 1.5 times we can multiply a 9, then we're going to get what? 27. So that's it what we have here. Principle expressing terms to the same basis goes by that. At times, it may be difficult again, then you'll be able to see as a mathematician, you just have to express the term to the same exponent. So the same there, it follows that say, if terms are expressed to the same exponent, like 5 is raised to the power, talk of maybe x raised to the power 5 is equal to talk of maybe 7 to the power 5. That it means much that exponents are the same. Then we have to expect here bases to be what? The same. Right, if terms are expressed to the same exponent. But the same bases, it means exponents are the same. If you express to the same exponent, it means the bases are the same as such. So sometimes it's very important to understand it and get to know and realize what is really involved in the exponential equation. Right, so at the moment, let us stop here. We will continue with other new examples in the next video. But I just leave you this assignment here to write. Try to find the power of m. How many times do we multiply 80 in order to get 0.25? As here we're multiplying 1.5 times in order to get what? 27. What about here? How many times do you multiply 8 to get 0.25? Thank you very much for being together. But don't run away, because we have another video very soon where we are going to have other examples that we need to really understand. So that at the end, we have to really understand how best we can solve the exponential equation. Right, thank you very much for being together.